discussing a recent presentation by Jitendra Malik he gave at Zurich, the Polytech in Zurich. Malik is one of the researchers we follow very closely because he's an interesting person, but I think also he is in line with our strategy of investing in robotics companies. His approach is learning driven, and he's trying to solve the data problem for learning-driven robotics manipulation. And he's coming from a vision perspective. So these are all kind of aspects that align with us, and that's why we follow. I also, this is in context with CVPR 2026, a conference we attended recently. So I want to talk about his presentation and then also make a few general comments about 3D vision reasoning, which is somewhat in line with what Jitendra is talking about, although he's not specifically pointing out. But the argument we want to make is the following, that once we solve a data navigation problem, which is what, a robotics navigation problem, which has been solved according to Jitendra, which I believe you can say has been solved also by Tesla in the full self-driving suite. So once that is solved, you have a couple of things that are necessary for robotics manipulation. In particular, you have solved reasoning and depth. So because you can't drive a car without understanding depth and the reasoning that comes with it. There's a tree in front of a car, so the car's before the tree, and I need to avoid the car and the tree, even though they're kind of subsequent, and the tree is not an immediate danger, but I can reason along those lines. Jitendra does divert a little bit from the Tesla strategy in terms of end-to-end training, and I don't want to go into that now, but the point is, what he's focusing on is 3Dification of video. That is the key message in this presentation, and that is also a paper they presented at CVPR, links in the show notes. Now, the idea is that you take, and he mentions what that actually entails, which he calls reconstruction. And reconstruction, I think he uses the word very meticulously, because it's not memorization. It's literally the same concept, like when we humans see something, whatever, let's say a coconut and a palm tree, we can kind of reconstruct a scene, a nice beach on a turquoise beach, water, sand. Like, we don't need to actually see every pixel of that scene. We also get a good sense for depth. We have a good sense for smell and feeling, because we do have, I guess we have a world model that reconstructs that. Or another way to say is, we have compressed lots of visual knowledge of the world, actually lots of sensory knowledge, visual, tactile, acoustic. So we can then reconstruct a scene from very little information. And that is the same approach that Jitendra is using here, 3Dification of everything. Now he's very focused on good enough. So he doesn't necessarily need to have a reconstructed 3D object that is perfect. So let's say an apple or a screw or a Lego block or something like, but it should be good enough for for training and simulation, because his pipeline is that we want to train a robot, we want to teach the robot certain skills, maybe basic skills, like, and he's using the analogy of a 5-year-old being taught by the father. So what the 5-year-old is learning from the father is primarily what he calls cultural and semantic ideas about the world. Yeah, you can go here, you shouldn't go there, this is heavy, this isn't heavy, that kind of thing. But the actual embodiment gap, so between what the father is doing with the ball and the son is doing with the ball in the backyard, there's an embodiment gap that the son is solving by watching the father kicking the ball, and then the son is trying on his own body. And this, Jitendra is suggesting, can happen in simulation. So that way you can reconstruct 3D objects and then teach the robot to manipulate them in simulation and then do the sim to real, which according to him is just an engineering problem. So this is roughly the pipeline. I think it's we're very excited about this approach because we believe that this is in fact exactly the way we think robotics can be solved. Now, I want to leave Jitendra's presentation and talk a little bit general now about the main takeaway from CVPR 2026, and that is that with the transferability of full self-driving into robotics, there is line of sight for us to see, at least on the technical side, how video reasoning, how video intelligence, how spatial intelligence and spatial reasoning can be actually leveraged, and that there is a case to be made for Tesla and others, but primarily Tesla, and that's what we care about here, and also NVIDIA to some extent, that once you have the self-driving technology, you can then actually transfer it into other types of robotics tasks, in fact, also into manipulation tasks in order to improve on manipulation, which of course, by definition, is not something that full self-driving is doing. You can then use Jitendra's pipeline, but you need spatial reasoning for that, and that is what FSD gives you. And I think I want to finish this comments just with one additional remark, and that is, the purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. So we talk about ideas here a lot, and this is, I think, a very good example of how we work. We go to a scientific conference, we listen to people talking about, representation learning, about how video reasoning can, improve spatial reasoning, how that can help robotic manipulation. Now, the reason we care about all this is because fundamentally we're interested in work as a service. So we're interested in the digital enterprise and the physical enterprise AI, which is a huge market that SpaceX, according to their S1, wants to tackle, and Tesla at some point, we believe, will be part of SpaceX, will help tackle with Optimus and chips and other additional contributions to the project. But fundamentally, what we believe in is that there is a line of sight, a technological line of sight, that can happen. So this is not just a science project anymore, and this is not just something where people just want to write a few papers and introduce new ideas at conferences. This is actually something that can be scaled. And the pipeline is that you have a pre-training phase, which is training from video, and we have the 3Dification of everything, which helps with training from video. So you don't just train the robot, the model, let's call it the model. You don't just train the robot from video, but you also 3Dify all the objects. So you can then train the model in simulation to manipulate the object. And the beauty about this is that once you have a certain number of object representations, these are composable. So then you can, you have a cup with on top of another cup, or a cup on top of a table. These are all composable objects. So you don't have to learn everything from scratch. And once you have that, you can then train in simulation how to manipulate those things. And fundamentally, you can then at some point also introduce the physics. That you can do with reinforcement learning. You can do with also in-the-loop training with feedback. We believe that the world models that will succeed will be the ones where you actually loop back from the real world, the video, the trajectory data of the robot back into the world model, and then have a data flywheel which drives the learning. So that's kind of the way we see it. It's not fully congruent with what Jitendra is talking about. It's actually not congruent with what anybody has been talking about CVPR. But this is kind of the picture that we see. So we see what Tesla's doing as a very big step in video reasoning from end-to-end pixel to actuator learning at scale, because they have the data and they can do it, and they also had the will and the investment to do it, and they have now a product that can be commercialized and improved, and therefore there's a data flywheel happening. We then have scientific endeavors such as Jitindra's and others, but mainly what's happening at Berkeley, in our opinion, is the most exciting work. And here we have the idea that we redefine everything and learn from video, and then use simulation to fine tune these learnings into manipulation tasks. And then lastly, and this is something that this is our own idea, we haven't really heard much from others about this, that we can then use this models in robotics, have the robots execute tasks, use them in shadow mode, learn from, well, because what you need in learning is counterfactuals. You always need counterfactuals. So you have to somehow build an environment where there's a counterfactual. For example, Tesla has done this with shadow mode. When FSD was trained in the beginning, it was trained on human driving, and the shadow mode was that when the model predicted X and the human did something else, the model would signal that there's something to be learned. So you need some sort of counterfactual. And in the world of robot manipulation, we can see that, for example, where the model predicts certain things, and if the robot does something else, it learns from that something else, feeds it back into the world model, and therefore starts building a world model where the actuator data and the physical interaction with the world is fed back into the world model, and therefore the world model is being improved. So again, to summarize, it is important for us as investors to see a technological line of sight for a very large market to be conquered, developed, embraced. I don't know what word you want to use, but fundamentally, of course, this goes back to our fundamental thesis, which is that anything which can lower costs, increase comfort, increase safety and convenience will eventually succeed. And I think robot manipulation, work as a service, digital and physical AI are those types of products. And we see a line of sight technologically to conquer that. And therefore, that is an interesting market for us. Thank you.